Look up at the sky tonight, and you'll see a vibrant, packed cosmos. We are living in a golden age of the universe, surrounded by billions of glowing galaxies and active star systems that feel like they'll last forever. But every single point of light you see is operating on a strict death sentence. If we fast forward the cosmic clock 1 trillion years into the future, we reach the darkest chapter of our universe. The absolute laws of physics dictate a systematic, irreversible dismantling of the cosmos. The bright sky we see today is a temporary state. This map shows the trajectory of our galaxy and our closest neighbor. Roughly 4.5 billion years from now, the Milky Way and the Andromeda Galaxy will collide, merging together to form a massive elliptical structure known as Milkdromeda. While that merger is happening locally, something else is driving the rest of the universe apart. Dark energy is forcing the empty space between all other galaxy clusters to accelerate at an accelerating rate. Fast forward 1 trillion years, and that expansion will push every other galaxy past a cosmic boundary. Because the space between them is expanding faster than the speed of light, the lines representing the light from those distant galaxies stretch out, completely failing to reach Milkdromeda. Any future astronomers living in our solar system will be physically blinded to the rest of the cosmos. When they look through their telescopes, they will see an infinite pitch-black void, and they will deduce that their single isolated galaxy is the entire universe. If we look inside the borders of Milkdromeda, the stars themselves tell a story of decay. Massive, bright blue giants and sun-like stars burn through their nuclear fuel rapidly, meaning they will have died out long before this era. The only survivors left in this dark era are red dwarfs. These tiny, faint stars operate on a highly efficient set of internal physics. This animated diagram shows the interior of a red dwarf. Notice the continuous circular loops moving between the core and the outer edge. This process is called stellar convection, and it means the star constantly churns fresh hydrogen fuel into its core, rather than letting it sit unused on the surface. Because they recycle every drop of their fuel, a single red dwarf can burn steadily for up to 10 trillion years, far outlasting the larger stars that extinguished near the beginning of the timeline. Any rocky planets locked in orbit around these dim red embers will serve as the absolute last sanctuaries for life, huddling closely for warmth around the universe's final burning fires. But even the most hyper-efficient star cannot outrun thermodynamics. Eventually, the red dwarfs must exhaust their fuel supply. To make new stars, the universe needs vast clouds of cold, free-floating hydrogen gas. But as each generation of stars dies, they permanently lock that matter away into unusable stellar corpses, such as white dwarfs, dense neutron stars, and black holes. This line graph shows the universe's total reserve of free hydrogen dropping steadily over time. When it finally plummets to absolute zero, the creation of new stars stops entirely. Astrophysicists call this the Degenerate Era. The final generation of red dwarfs lack the mass to explode in fiery supernovae. They will simply fade away in the dark, cooling into dense, dead spheres of helium and carbon known as black dwarfs. The universe will have officially gone bankrupt of its most vital resource. Once the last black dwarf cools, all starlight in the cosmos is irreversibly extinguished. What remains is a pitch-black graveyard. The new rulers of space are completely dark, dead stellar remnants, including cold white dwarfs and ultra-dense neutron stars, and spinning pulsars ticking away like lonely cosmic metronomes in the absolute silence. Occasionally, gravity pulls two of these dead remnants together. They spiral inward, releasing a sudden violent flash of light before the void instantly swallows the space back into total darkness. The final inheritors of this dark reality are supermassive black holes, quietly lurking in the center of dead galaxies and slowly consuming whatever stray rocks or dust drift into their paths. In this ultimate era, the universe is physically stripped of light, warmth, and information. It becomes an infinitely cold, quiet void where the vibrant past is entirely erased. Now, pull yourself back to the present day and just look out at the sky above us tonight. Our current existence is packed with specific, temporary luxuries. We have neighboring galaxies we can clearly see and study, with brightly burning stars to navigate by, and a sun that showers our planet in steady, life-giving warmth. Seeing exactly how the universe ends shifts our perspective on right now. It leaves us with a profound gratitude for the sheer luck of existing during this vibrant, fleeting window in cosmic history. If you want to keep exploring the deep mysteries of our universe, hit the subscribe button and click the video on your screen right now to jump from the distant future to the present day and discover the